Is it true that cloud weighs over 1 million tons? That is like stacking over 5,000 jumbo jets all together, because the fully loaded Boeing 747 airplane weighs 200 tons. This whole cloud weight situation is one of those scientific facts that simultaneously makes perfect sense and sounds completely made up. It's like when someone tells you that a group of flamingos is called flamboyant. It's technically true, but it feels like someone was just having fun with the English language. Except in this case, we're dealing with actual physics, and the numbers are even more ridiculous than you think. Let's start with the basics, because apparently we need to have a serious conversation about cloud mathematics. The average cumulus cloud, that picture perfect cotton ball clouds that make you want to lie in a field and point out shapes, span about 1 kilometer in each direction. That's roughly 1 billion cubic meters of space, which is already a number so big that our monkey brains weren't really designed to process it properly. Within that massive volume of seemingly empty sky, there is approximately 0.5 grams of water suspended in every cubic meter. Now, 0.5 grams doesn't sound like much. It's less than a paper clip weighs. But when you multiply that tiny amount by 1 billion cubic meters, you end up with 500,000 kilograms of water just casually floating above your head. That's 1.1 million pounds, or roughly the weight of 100 adult elephants having a mid-air party. The US Geological Survey, which apparently spends time thinking about these things so the rest of us don't have to, confirms that yes, this is actually how much a typical cumulus cloud weighs. The Library of Congress backs this up too. Now, before you start panicking about elephant weight water bombs potentially falling on your head, let's talk about why these massive floating water reservoirs don't just crash down and ruin everyone's day. It turns out that clouds are basically the atmospheric equivalent of that one friend who looks way heavier than they actually are because they are wearing layers. The cloud's density is about 0.4% lower than the surrounding dry air, which means it's technically lighter than the equivalent volume of regular air would be. It's like how a helium balloon floats, except instead of helium, it's water droplets that are so incredibly tiny, they make dust particles look like boulders. These water droplets are between 5 to 30 micrometers in diameter, which means you could fit thousands of them across the width of a human hair. They are so small that they basically spend their time getting bullied around by air molecules, keeping them suspended in a cosmic game of atmospheric pinball. Meanwhile, the water is spread out over such a massive volume that the density ends up being lower than you would expect. Kind of like how a huge bag of popcorn can weigh less than a small bag of rocks. The water content in the cloud isn't evenly distributed. At the base of the cloud, there's basically zero water concentration. As you move towards the middle, you hit the sweet spot, where you can find up to 1.2 grams of water per kilogram of air. Then it gradually decreases as you head towards the top. It's like nature decided to create the world's most insufficient layered cake, except instead of frosting, it's water, and instead of being delicious, it's just very, very confusing. This whole setup creates what researchers call a buoyancy paradox, which sounds like something a physics professor would name their band. The cloud contains an enormous amount of water, but it weighs less than the air around it. It's basically the atmospheric equivalent of wearing a heavy coat that somehow makes you lighter than if you were naked, which makes about as much sense as most things in physics do. Different types of cloud take the weight game to completely different levels. Your basic cumulus cloud, with its 500-ton water content, is actually the lightweight champion compared to its bigger, angrier cousin, cumulonimbus cloud. Those towering storm clouds that look like nature skyscrapers can stretch 10 kilometers in every direction and contain about 2 grams of water per cubic meter. Do the math on that and you are likely at roughly 2 million tons of water suspended in the sky. That's like having 400,000 elephants floating around up there, which sounds like either the setup for a very strange cycles or a very specific nightmare. Stratiform clouds, meanwhile, are the overachievers of the cloud ball. These are the layers that can stretch 500 kilometers across and hang around for hours, looking like the sky ceiling got painted grey. They might only be 200 meters thick, but when you're talking about covering areas the size of small countries, you end up with clouds that weigh up to 10 million tons. At that point, we're basically talking about aerial lakes that decided gravity was more of a suggestion than a law. The University of Reading, which apparently has researchers dedicated to weighing things that float in the air, has confirmed these numbers through what must be some of the most interesting field research in academia. They've calculated that even smaller cumulus cloud weigh around 250 tons, which is still equivalent to 2 adult blue whales, deciding to take up residence in the atmosphere. The fact that we have precise measurement for this stuff suggests that somewhere there are people whose job description includes cloud weight specialists. And honestly, that sounds like a pretty cool career path. Recent research from the National Center for Atmospheric Research has revealed that cloud water density varies significantly with altitude, creating what's essentially an invisible layer cake of moisture floating above us. The concentration starts at zero at the cloud base, peaks somewhere in the middle, and then gradually decreases towards the cloud top. The implication of all this floating water way go beyond just being a cool, fun fact to impress people. These measurements help meteorologists understand weather patterns, predict rainfall, and figure out why some clouds decide to rain while others just float around looking decorative. It's also crucial for aviation because pilots need to know they're potentially flying through the equivalent of a suspended lake, even if it doesn't feel like it. Climate scientists use these weight calculations to understand how much energy is stored in the atmosphere and how weather systems develop. When you realize that every cloud represents hundreds of tons of water that could potentially fall as rain, snow, or hail, it puts extreme weather events into perspective. That gentle spring rain that makes everything smell nice. It used to be part of the floating water reservoir that weighed more than most buildings. The physics, which clouds don't fall despite their massive weight, involves concept that sounds like they were invented by someone who was having way too much fun with science. Air density, buoyancy, particle suspension, atmospheric pressure gradient, and thermodynamics all work together to keep this aerial water storage unit floating. They are defying common sense. Weather prediction is still such a challenging field. When you're dealing with systems that involve millions of tons of water suspended in constantly changing atmospheric conditions, influenced by temperature gradient, air pressure differences, and wind patterns that can shift by the hour, it's no wonder that meteorologists sometimes get things wrong. They're essentially trying to predict the behavior of aerial water reservoirs that weigh more than cruise ships and can appear or disappear based on invisible atmospheric conditions. So the next time you're lying on the grass, looking up at those innocent-looking white balls drifting across the sky, remember that you're basically stargazing at a floating water warehouse. Each one contains enough liquid to fill several Olympic swimming pools, way more than a fleet of trucks, and is held up by physics that would make Isaac Newton scratch his head and probably invent a few new laws of nature just to understand what's going on. The fact that we live under this constant parade of floating waterway, completely oblivious to the aerial tunnel drifting overhead, is probably one of the better arguments for why reality is significantly weirder than most people realize. We've just gotten used to treating £1 million water collection floating in the sky as completely normal background scenery, which says something profound about humanity's ability to adapt to absolutely anything, no matter how bizarre it actually is when you stop and think of it.